Okay, I'm continuing with the math polynomials, and I'm not sure why this is so big. And I've gone in and I'm going to look at cube through square root, and specifically two of them, just because the other ones make things so small. But basically looking at square and cube, probably not cube root or square root. I'll show you what happens. And I'll build this geometry and show you how it's made using a plugin Hoopsnake, which allows you to make iterations of things. So I started with pi because pi is beautiful, and I put it through a domain, positive and negative, and had a range of numbers. That range of numbers I decided I would bring into Hoopsnake and have feedback. So instead of just bringing it through to take that range and put it into points being affected by square, and I did have cube, but the numbers got too big. You can always substitute this in, and you can always substitute in the other two as well. So whatever you choose to substitute in, I find a squared works very well. And you could write equations in the expression file, or you could write the function tools. But this is a nice way of using nodes and seeing if you can kind of visualize what's happening. So I built some points from that iteration, and I run it through, I think just twice. So, well, 0, 1. So it goes through twice, and it gets two forms. Then it takes apart those points so I can play with the x. And when I play with the x, I throw it through a range that takes it into a graph mapper, which is very similar to what just happened with the square root, except I'm using sine now. And I can play with the shape and change that, and you'll see the geometry updates when I do that. Could be a little slow here, but let's just see what happens. There you go. It updated very subtly down there in the bottom. It's still updating because I'm doing it early in the script, and the script's fairly long. So let's just continue with still putting it on turntable. It should go quicker as we move in. And you see all these lines are being variable piped in different ways. I have a multiplier on it that allowed me to obviously bring in this graph mapper, and then I reassembled those points. And those points are made again. Now what's nice is you can see everything as I go through. So I start with those original points, which are fairly boring. I take them through this iteration, and I end up with this kind of affected curve that can be interpolated and make this funky shape that's jittered and shaken. I then take what's coming out as feedback into another point. And at this time, I think possibly putting this in could have a major effect as feedback, because the feedback loop is basically coming here. But sooner or later, the feedback, when it's done the iteration, I want to take the information out. And you'll see that there was the point affected by it. And I put it through the same thing again. I ran it through the same script, and this time I threw in a cube. So square root and cube root, and brought that into Z. And that generates this kind of wonderful point system, which can be interpolated. And then again, I affected that one by going through and pulling that into another sine curve. Now, keep in mind, I don't have to use that sine curve. I could offset the graph mapper to anything. And those geometries are really, really controlled. Again, pipes are generated, a really nice system of pipes here, and kind of an elliptical formation, but also flattened and U-shaped in the bottom with a concentration of points. I take all of them, which are great series of lines, which are generated by the cube and the square root, and I interpolate them, and I still have one more effect on the parameters of pulling the radii into the 0 to 1 parameter. That said, I dispatch them into different areas, and I color them differently. And Ella's making up quite a bit of noise over there, which is fine. And you can see the colors as I could split them up more into exploded trees and have them in many different colors, but this is quite an interesting shape that's made from using those simple nodes. And this interpolated curve, I'll just pull back into here to group, and that should be it. So you have many, many controls over that. Now, like I said, you could put that into an expression, and you'd have to be able to write some pretty cool mathematical expressions and have total visualizing code on it. What I like about this is for the visual artist or designer, you can actually see those and affect those curves in a graph mapper way, and play with the Hoopsnake. Believe me, if you take it to more iterations, it just explodes through the roof because you're exponentially growing so fast. So you have to watch your data. You have to keep seeing what's coming out as points, and you want to keep referencing. And it's a great example of using geometries, getting back into the points and realizing the points are informed by numbers, which then in turn allow you to build the geometries from those points. So a nice little example of polynomials. We will continue with 1 over x, the power of 10, the power of 2, the power of e, a logarithm. And you're going to find that these things are so exponential in a sense of tied to calculus, you might lose your visualizations of geometries. But that's a 5-minute video. Hope you enjoy.